Hello, Algebra 2 folks, and welcome to Graphing Exponential Growth and Decay Models. You need your notes, a calculator, and a pencil, and we will get started. All right, would you rather have option A, $10,000 given to you every day for the next 30 days, or option B, a penny today, but I'll double it every day for 30 days? Well, let's take a look at some tables. Here, the first table says by day 9, I'm going to have $90,000. By day 10, I'm going to have $100,000. So that looks like a pretty good option. Most of you are probably saying you want to take option A. So let's look at table B. By day 9, I'm only going to get 512 pennies. That's only $5.12. That doesn't look very good. I'm thinking option A is where most of you are going to go. But what if I told you that option B, by day 30, you got $10,737,418 and some odd cents? And what would option A give you in 30 days? Only $300,000. Now which one are you going to take? Option B. This is what exponential growth does. It starts off really slowly, and then by day 10, 15, 20, it just skyrockets. And that's what exponential growth is. It starts off slow and then skyrockets. All right, so I'm hoping all of you now would take option B. All right, now we're going to go ahead and talk about what are some examples of growth and decay in real world. Well, things that grow or decline at a certain rate would be bank account, interest. You know, your interest is going to grow. Population. Population can grow or decay. Radiation. That's definitely decay. Depreciation of your car. So you buy a car, you take it off the lot, and it depreciates. Fossils, carbon content in fossils, carbon dating. That's how they determine how old mummies are. And that's a decay. So these are some good examples to have in your notes about what grows and what decays. Okay? Here's an example of what growth and decay graphs look like. You know, the general shape. We're always about the general shape. So here's the general shape of a growth graph. And notice growth starts out low and goes up high. And decay graphs start out high and go down low. Okay? So the goals for today will be that we'll be able to graph exponential growth graphs and decay graphs. You'll be able to identify the domain and the range of the graphs, and that you will learn about a new term called asymptotes and how to identify them on your graph. Okay, that's going to be the new word for today. So what does an exponential model look like? Well, an exponential model looks like this. Every function that we talk about has a generalized equation or generalized y equals something, right? So this is what an exponential model looks like. Notice the x is in the exponent. That's why it's called exponential. The b is the base, okay? And so if you have an exponential growth function, b is going to be greater than 1. That's called your growth factor. So your base becomes your growth factor if b is greater than 1. It becomes your exponential decay factor, or a decay, if your base is between 0 and 1. All right, so let's go ahead and graph an exponential function. All right, so we look at the base. Here we go. Here's the base. The base is 2. That is greater than 1. Therefore, this is going to be a growth graph. Okay? Now, how do we know what we can plug in for x's and y's? Well, let's talk about what x's we can plug in. Do you see a division sign? Nope. And the 2 is a positive number. This number is always going to be a positive number. It's never going to be negative. So we never have to worry about maybe taking it to a power of 1/2 or anything like that, because the 2 is always going to be a positive number. So we can say that we can have any value of x we want. So x such that x equals all real values, because we don't have those two things that we think will cause problems, dividing by 0 and square roots. So I'm going to go ahead and plug in -2, -1, 0, 1, 2. Those are going to be my x values. Now, when I plug in -2, I'm going to type in 3 times parentheses 2 to the -2 in my calculator, and I'm going to get 0.75. -1 is going to give me 1.5. 0 gives me 3, 1 gives me 6, and 2 gives me 12. And when I plug those onto my graph, okay, this is what it looks like. That general shape. Okay, now the graph is never going to touch 0. Here's how I know that. If you were to plug in -10 for x, your y value would be 0.0029. That's really close to 0, but it isn't quite 0. If you plugged in a -100, your y value would be 0.0000000, 30 zeros. You would have 30 zeros, and then 87 something. So I know that that is really close. That's super close to 0, but it's never going to touch 0. Okay, now think of this. If you don't have any money in your bank account, can you earn interest off of it? Nope, you have to have at least a cent in there. Okay, so the asymptote is y equals 0 because it's never going to touch y equals 0. Okay, it's going to approach it but never touch it. And so then the range is, what are the y values that this graph will always touch? Well, bigger than 0. So y such that y is going to be greater than or equal to 0. Okay? And so the asymptote and the range go together. All right? So I've used the word asymptote, and you're probably thinking, what is an asymptote? So let's go ahead and look at this graph. This is an exponential growth graph. I know it's a growth graph because it starts out low and then it gets really big fast, okay? So what is an asymptote? Well, an asymptote is a line that a graph will approach more closely, inch by inch, centimeter by centimeter, millimeter by millimeter, but it'll never touch it. It never truly touches it or crosses it. So the asymptote of this graph that you see here is that it is getting closer and closer and closer to 3, but it is not going to touch 3. So the asymptote would be y equals 3 in this case. Okay, so let's graph another one, knowing that we know what an asymptote is. Okay, let's look at this one. Here's the 2. I'm always putting that in parentheses so that I know what the base is, so that I can tell if it's growth or decay. If it's greater than 1, then it's growth. If it's less than 1 or greater than 0, it's decay. So in this case, it's greater than 1, so this is a growth graph again. Okay, but now the graph is moving down 5. Guess what? The up and down affects the asymptote. So I already know that the asymptote is going to be -5 here because it shifts, the graph completely shifts from being at the 0 mark down to the -5. So I already know the asymptote is -5. Okay? And then the range is going to be greater than or equal to -5 because my graph is going to go up because it's a growth graph. Okay? So I need to plug in some x and y values. Now, if I do -2 to 2, I am going to see more of a straight line. So because this is being shifted right 3, I'm going to go ahead and start my graph at 0 or 1 so that I can see a nice true graph. Rather than starting at -2, I'm going to move it down just a little bit more. I'm going to move it right a little bit so that I can see a true exponential growth graph where I see that true picture. Otherwise, if all my points are down here and I never get that curve, kind of like with the pennies. I mean, we never really got bigger and bigger and bigger, but so if we don't see that curve, then it's not going to look like a nice exponential growth. So if I plug 0 in, I would do 2 parentheses, and I do a caret, and then make sure you do 0 minus 3 in parentheses, then subtract 5. When I do that, I get negative 4.87. Look at that. It's not going to touch negative 5, but it's going to get awfully close to negative 5. If I plug a 1 in, I get negative 4.5. If I plug a 2 in, I get negative, I get 4.75 for 1. I get negative 4.5 for 2. For 3, I get negative 4, and for 4, I get negative 3. So let's plug these in here and see what happens. So 0, negative 0.87, okay, 4.75, negative 4.25. See how they're all so close, and I'm not even really seeing any curve. Let's see what happens. Negative 3, 4, 3, negative 4, 4, negative 3. Okay, now I'm starting to see that curve. Okay, so I bet you that this is probably going to be 5, negative 1. I might do one more so that I can see the nice general shape to see that it's going to curve up like that. All right, and then the domain is x such that x equals all reals, always. That's what that always is. This always comes from our shifting up or down, and then we can figure out the range based on our asymptote. All right, let's do another graph. So this time I have f of x equals 1/5 to the power of x plus 1, and now I'm looking at this guy right here, and that value is less than 1, so this is going to be a decay graph, so this is going to look like this, okay? So we're looking for that general shape of starting out high and going down low. Okay, our shifting is up 1, therefore our asymptote is y equals 1. So I'm going to go ahead and draw that y equals 1 in there right away. And I didn't have any right shifting, so negative 2 to 2 is perfect. If I don't have any left or right shifting, I'll just stick with negative 2 to 2. So negative 2, if I plug that in, 1/5 in parentheses to the power of negative 2 plus 1, I am going to get 26. If I plug a negative 1 in there, I'm going to get a 6. If I plug a 0 in there, I'm going to get a 2. If I plug a 1 in there, I'm going to get a 1.2. Woohoo! Awesome! We beat Red River. Okay, so sorry about that. And then 2 would be 1.04 when I plugged it in my calculator. So negative 226 is way up here, so I'm not going to plot that one. Negative 1.6 is right here. 0.2 is here. 1.2, 1.2 is there. Oh, look at that. See how it's going to approach 1, but it's never going to touch 1. So that's why that's called our asymptote. Our domain is all reals, always. And our range is y such that y, all our values are above that 1, so greater than or equal to 1. All right, so that's the end of graphing. Now if I had you classify exponential models, and I just gave you these equations, I would expect that you would be able to tell me if we're talking about growth or decay. So you always look at what has the exponent of an x on it. So that's this guy right here. Is that greater than 1 or less than 1? It's greater than 1, so this one's growth. Okay, 0.3. Well, that's less than 1, so this would be decay. 3/5. That would be less than 1, but greater than 0, so that's decay. 7/2. This is tricky. You think that 7/2, because it's a fraction, is less than 1, but not all fractions are less than 1. This is 7/2, which is 3.5, and that's greater than 1, so this is a growth graph. All right, so hopefully you can identify growth and decay graphs. Hopefully you can graph growth and decay graphs. Hopefully you are kind of starting to understand what an asymptote is. We'll talk more about that tomorrow. And that you understand the domain and the range. Thanks for taking good notes, and we will see you tomorrow.